After completing this lecture, you can recognize data structure and processes. First, we have structured data. This type of data is highly organized and easily searchable. It is stored in fixed formats like spreadsheets with clear rows and columns. Examples include transaction records, customer information, and inventory data. Structured data is straightforward for AI models to process and analyze, making it suitable for training basic machine learning models on a specific, well defined tasks. If the structured data is or can be transformed into numerical formats, then we can directly apply statistical methods for data analytics. Classical data visualization can also be used to gain insights from structured data. Next, we have unstructured data. Unlike structured data, unstructured data lacks a predefined format. It includes diverse type of information, such as text documents, images, videos, and social media posts. While it contains a wealth of information, it's more challenging for AI models to process due to its variability and complexity. However, advances in natural language processing, computer vision, and other AI technologies are enabling the extraction of meaningful insights directly from unstructured data without pre-structuring and labeling. Lastly, we have semi-structured data, which is the favorite data structure for AI researchers. This type of data falls between structured and unstructured data. It does not reside in a fixed format like structured data, but contains tags or markers to separate elements, making it somewhat easier to analyze. Examples include XML files, JSON documents, email messages. Semi-structured data provides a balance, offering flexibility while still retaining some level of organization. In summary, structured data provides clarity and precision. Unstructured data offers depth and richness, and semi structured data bridges the gap between the two. Most established AI models depend on extensive training and evaluation using semi structured machine learning benchmark datasets. These datasets are not just collection of data, they are crafted to challenge and refine AI models in a controlled setup, making the creation of these datasets an expertise driven process. Collaboration among data engineers, domain experts, and crowdsourcing scientists is crucial to develop these benchmarks. Each contributor brings a unique perspective that enhances the dataset's quality and relevance, ensuring that the AI models trained on these datasets can perform effectively in diverse and real world scenarios. However, the data's socio-technical nature also introduces imperfections, such as biases. Biases in datasets can arise from a variety of sources, introducing the subjective decisions of those involved in the dataset creation, historical data inaccuracies, and inequalities that are captured in the data. These biases can lead AI systems to develop skewed understanding and outputs, which may impose existing disparities or introduce new ones. Therefore, the challenge lies not only in structuring and cleaning data, but also in continuously updating the datasets to address and mitigate these biases. This ongoing process involves employing advanced statistical techniques, ethical guidelines, and inclusive practices to ensure the data reflects fair representations. In conclusion, the task of creating trustworthy and challenging benchmark datasets for AI development is extensive and critical. It requires not just technical skills, but a deep understanding of the social implications of data. By acknowledging and addressing the inherent imperfections in data, we can pave the way for more robust, ethical, and effective AI systems. Let's look closer to the process of creating a dataset for AI training from the technical perspective. At the beginning of the journey, we start with very raw data from various sources and modalities. This can include public data, social media, and analog data. This raw data is unstructured and lacks organization, and it exists in multiple platforms, or it is not even digitized. The next step involves structuring this raw data by storing it in a database. This includes using repositories and achieving the data in formats like SQL, which helps in organizing and managing large volumes of data. Once the data is stored, it undergoes a cleaning process. This involves anonymizing sensitive information, selecting relevant data, and performing tasks like enhancing, trimming, and balancing the data. Data cleaning ensures that the information is accurate, consistent, and ready for further processing. Following data cleaning, the data is annotated. This step may involve human supervision through platforms like Mechanical Turk annotations and context and labels to the data, making it suitable for training machine learning models in a supervised manner. Finally, the annotated data becomes a well-structured data. This data is now ready for use in machine learning and AI applications, providing a robust foundation for training models. Just as crude oil requires refining before it can fuel your engine, data must undergo a refinement process before it can be effectively used by machine learning models. This comprehensive journey, which I refer to as the data refinery process, is essential for transforming raw data into a valuable resource for AI learning. Often this process is understated in machine learning, while I believe a competent ML solution starts with a good data set.